Welcome to this week's lecture when we will be considering literacy and numeracy across school disciplines. So this is the sort of content area where we'd like you to be infusing into your discipline studies, so that when you are looking at how your discipline is organised, how your discipline is organised as its content, how it structures around its outcomes and skills and all the sorts of things that make up your particular discipline, that you also have this sort of voice in the background saying what's the literacy and what's the numeracy that might support the learning in this subject area. And so we'll talk a little bit about that in this lecture. So before we start looking at that, maybe you could go back and consider your own experience of being at secondary school, whether it was recently or not so recently. Your secondary school setting will have been a place of differentiated disciplines. So you might be able to think about how many subjects you did, how many different subjects, or were subjects combined in some way. Particularly where subjects were separate and clearly defined as by being named at different times. What sort of connections did you have between those subjects, or were there any connections made? This is a big thing for thinking about the student who is one person who's popping between the different disciplines. What connections are teachers making to show students that, yes, this is my discipline, but these are the connections between the disciplines? And that can be easy to do and sometimes quite difficult to do. Did your school have something like thematic programming, where you might have had a theme across a number of subjects? Maybe, I don't know, recycling or sustainability, to bring in some more modern sorts of themes, or history, and then different disciplines tapped into that thematic sort of area, usually around a content rather than a skills area, and then your own discipline looked at how that theme could be realised or organised, or we could build knowledge in that sort of particular theme. Some schools will do it around questions. Primary schools particularly do this, but sometimes secondary schools do as well. The big questions of the world, and then trying to look at how that discipline answers those questions. Whatever your experience was of high school, you may be quite aware that there are ways of doing particular subjects, that the discipline itself points itself in a way of thinking about the world, or investigating the world, or commenting on the world. And what we want to do is look at how disciplinarity, how these disciplines create the particular knowledge that's built in the discipline. And then what is it about the ways that language and mathematics can help build that knowledge, so that in getting good deep knowledge in your discipline, you might need deep thinking, and through deep thinking you're going to need deep engagement with both the language and the mathematics of the world. And we need to keep in mind too that, as we saw, we've had changes in the way literacy has been understood. There are movements in the way disciplines actually understand their own knowledge base, and we've probably had this move between, or we looked at integration and interdisciplinary sorts of understandings, where we're looking for commonalities between subjects, and this is sometimes seen as breaking down barriers. Assuming there were barriers there in the first place, that we find the commonalities. We sometimes we might be doing this sort of integration without really understanding the importance of knowledge itself, and in order to adapt and to apply to changing circumstances. So we need to make sure it's not just a mush of subjects, that sometimes thematic programming became a point where you couldn't see what you're actually learning, that it was all about just the process and not the knowledge being built. So these days we probably think a little bit more about the knowledge being built. And probably these sort of debates that started to emerge in the 50s and the 60s, this difference between sciences and humanities, as though they were two very separate and two very different ways of looking at the world. And you know, we can say there might be a scientific way. Is there a humanities way? What are the humanities? Some of the things that we talk about, humanities has a very logical step-by-step processing that we might think of as science. So we've just got to be careful of polarization, because if we do have too much polarization, then we can't see also the commonality. So it's quite a balance here. We want to think about your discipline as having its own way of thinking about the world and its own knowledge, which may have relationships to other bodies of knowledge, other disciplines as well. And in fact, Christie and Maitland would suggest that to portray the disciplines as rigid and fixed and only that way of doing things is probably a little unfair, and it doesn't understand the nature of knowledge itself and how we create knowledge. So there may be a mathematical way of looking at the world, but it doesn't preclude us from getting to maths in other ways as well. Just as English might have a particular way it understands the world and understands knowledge, that doesn't preclude us from using other ways of getting there as well. However, there are sort of stereotypical ways that we organise subjects. Your question is that the way you think about the subjects? And if not, how are you going to be able to manage that? How do you build your students, how do you apprentice your students into that subject? So disciplinary knowledge, and the readings for this week will look at some of the work from the Shanahans, there's two Shanahans, and other friends. But disciplinary knowledge is the way that information is created, shared and evaluated in a particular subject area. So it's a conceptual lens employed by the discipline to look at the world. And so we want to foster that sort of disciplinary sensitivity in practice. So we're not saying, we're not trying to resist the ways of thinking about our subject areas. We want to look at them and understand those, and then see how we identify, I guess, within those disciplines. And there's a lot of research around identity, identity as a scientist, identity as a mathematician, identity as a business, I guess, a business person, or in commerce, that sort of thing, in all the different disciplines. And so the other thing that we'll be looking at in the readings, of course, is this idea of the disciplinary learning as distinct from content area learning. So content area learning, you'll read a bit more about, is more this generalised understanding of how we deal with non-fiction, if that's a way of thinking about information text. So the sort of things that you might do if you went along to one of our UTS library sessions, where you're taught how to do academic reading in a generalised way. The challenge then is to understand how that academic reading is done in your content area. So how do scientists do reading? How do mathematicians do reading? How do English students do reading? And we know that these have different, because they have for different needs, different end purposes, then we read in different ways. One may be starting from the beginning and working your way through to the end. That works for a novel. That doesn't work for other types of text, and would be a little waste of time to do that. So we want to distinguish between those more generalised skills for content, which are good and come under that general academic sort of learning, which we want to foster in our own students at high school. And then we need to say, how do we apply that into our specific discipline? So if we think about literacy, there's that generalised idea about, yes, I can get information, but then how do I get that information in my content area? The same for numeracy. There's general numeracy ability. How do we apply that to our PDHPE topics, particularly when we're dealing with sport versus our science, our health sector of that, for example? How do we utilise those that mathematical ability, that numeracy, when we're looking at commerce or economics? So we want to, there's a general building of knowledge, and then there's a specific use of knowledge, which then builds more understanding. So let's just take science. I've talked a bit about science, but let's take the case of science, the way it's changed over, this discipline has changed and is in the process of changing. Generally, this idea of inquiry has been at the heart of a lot of science education. It's something that was sort of came out, I remember it coming out in the 80s, and in that time it was also in social science, this idea of inquiry, and it's still very much part of how social, the HISI area is organised in primary school, that it's a way of discovering knowledge. Well, this sort of puts a personal personalised or individual construction on science, that I myself will inquire and I will discover knowledge. So the idea is that it changes my perspective on the world. So I do science and I do inquiry so that I can change the way I see the world. So a personally sort of rendered idea of knowledge. What's happening, and it's starting in America with the new, the next generation science standards, for example, are reorienting this idea of inquiry. So what they're saying is it's not actually a personal, we don't do science for personal pleasure or personal knowledge or an individual pursuit. In fact, by moving inquiry into meaning and understanding of practices, we're starting to see that the role of the teacher is a means to direct the acquisition of scientific knowledge, and not just personal scientific knowledge. And as Osborne says, not to create new knowledge, but to help students to understand a body of existing knowledge, consensually agreed and well established knowledge, so that students aren't doing inquiry to make discovery. They're doing inquiry to understand what we already know about science. So this is a shift in the way science education is being understood in the States. It may have impact, it may already have impact on the way teacher education is being organised here. I'm not sure exactly how UTS is doing it. But this example, a case study, is just to show that what we understand as the way we position ourselves within a discipline changes over time. And we can see the change over time as well as through high school. So what we do with science, for example, in the early years of schooling is quite different to what we do in the towards the end. And Robert Veal's work is really helping us to understand how particular knowledge is organised with the idea in Veal's work particularly, how does literacy support this change in the way disciplines are organised? So if we've got this worldwide understanding of science changing, how does that impact then on how we do science from primary school through to high school? And Veal's work really looked at how in the early years we moved from this doing science, we're apprenticing students into scientist-like activities. We want them to feel like scientists. In primary schools they put on white coats and pretend to be science and put too many pens in their pockets, that sort of thing. So we're really trying to get kids into doing science, and it's very activity-based. And as we move up into the middle years and into high school science, we're still doing things, but the emphasis more on being able to explain scientifically why this doing science works. What is at the base of this? That's not to say that little kids aren't also doing explanations. They are, but the emphasis is more on the doing, whereas we start to move into this explaining scientifically, and at the same time as that we have this organising scientific information. So we're trying to get a handle on data, so we use bigger data sets, for example, than we would in primary school. So there's more numeracy going on, of course, in that sort of activity. So we want students to organise more groups of information, to be able to draw on information that they have worked on during experiments or maybe through research, and then to start using their scientific knowledge to explain what science is all about. And as we move up into the later years of high school, this idea of challenging science, of looking for where it could be used. So it's not just arguing science, but where is the challenge of science as well? What is it going to be used for? And then arguing back and forth about how that might be used and the appropriateness, for example. So if we're thinking about how science then changes over time through high school, as well as these outside changes that are impacting on the way we even think about science, literacy and numeracy becomes quite basic then to how we work with our scientific information. So for example, in that early understanding of science, students' literacy will be around, we investigated. It's often this personalised sort of understanding of what I did as a scientist. So the language might be a bit more everyday, and again, trying to make science accessible. We use everyday terms. As we move up through high school, of course, we want to put that much more specialised vocabulary into it. I'd argue in primary school we want to start doing that as well. So our language will move. If we're explaining science, then we need to use a different language. We take the personal out, for example. These results suggest, this process indicates. So we're pushing language to say, I'm going to now do something with what I've just been finding out. I'm going to explain, I'm going to extrapolate, that sort of thing. And indeed, with our organising scientific information, there's a lot of numeracy there to do with data management, data display. Of course, these things are working together. We want our numeracy to be working well, so that we can write about it or we can do something with our literacy. So these need to work together. And of course, as we move up through science, if we're challenging science, then we might need to be moving into language that again is very depersonalised, works with the content, not with the person. It appears that action should be taken. So we might have, in that first example, modulated language. In science, part of the discourse is not to say this is the way it is. We suggest, we propose, that sort of thing. However, when it comes to action, it's often a bit stronger. So once we've proposed, we might say we should. So it's a bit of a, it's interesting working with these sorts of language resources when we're working in science. So a lot of language to do something with science, not just to, well, even the finding out has a lot of language and literacy and numeracy, and then what we do with it, we start to pull on different resources. If we just look briefly at history, one of the main ideas or the main changes in history education is this dismantling of time. So the work of Carolyn Coffin really looks into this. By looking at what's in the syllabus, we can start to see that these sorts of patterns arise where we play with time. We start with a very personalised look at time, my own time, and if you look at very young children's work with history, it's all about my history, my family's history, and so we work around time, recounts, historical accounts, we start to put in causality, and then at some point around about high school, and this is the big change in high school, it's not just a big school, it's the way that we start to ask students to deal with knowledge, we dismantle time. And so actions and historical concepts are not rooted in the time that they happened or the sequence, but this abstraction into concepts, this exposition, arguing, challenging history. So there is some time, but it's more about the concepts of colonisation or I can't think of any right now, but the sort of historical concepts. We discuss the concept, not the time in which it happened, though that becomes part of our support. So I guess what we're trying to get you to think about really here is what is it that happens in your subject area as you start to deal with the syllabus. If I just show you history just for a minute, and this is what, when you start to look at your syllabus, you might be able to do the same sort of tracing through. At stage 1, we're communicating. There's communication, so we've got literacy happening here. We're communicating an understanding of change and continuity in family life. By the time we get to stage 6, we're still communicating about continuity and change, but now we have to account for this and we propose arguments about the cause and effect. So we have the same idea, historical concept of continuity and change that goes all the way through the syllabus, but we ask students to do something different with the thinking and therefore something different with their language at these different stages. And so if we were to trace through all the way through from stage 1 through to stage 6 in history, we see this continuity of the idea of change and continuity being recycled and then expanded upon as we work through schooling. And at each point, the language is being asked to do something else, and probably the numeracy as well in terms of timelines and all sorts of other numerical sorts of attributes. So if we just look for a minute, we go to stage 2, we're identifying. So in stage 1 it was communicating, however you like. By stage 2 we need to identify. Stage 3 we're looking at describing and explaining. When we get to stage 4 it's describing and assessing. And then we've got explain and analyse, and then we've got account. So each of these words are telling us it's a slightly different literacy activity. So the way that we use language to describe and explain is different to how we describe and assess and how we explain and analyse. So if you were a history teacher, which I know none of you are going to be, you would need to be thinking about, as you're looking at the history syllabus, the sort of literacy that would need to underpin these sorts of activities. So as you're looking at your syllabus for your subject area, if you're tracing through particular concepts or particular strands, you might be thinking or just looking at the sorts of words that are used to describe your syllabus steps, to think about what would be asked of students. What do you need to make sure is being taught? So if we go back to the beginning, it's not just that generalised literacy, content area literacy, but what's the discipline literacy and the discipline numeracy that underpins your particular area as we move through the schooling stages. So particularly your interest in stage 4, 5 and 6, it's always useful to go back and see hopefully what they did at stage 3 to see where they are even with their literacy stages. So at every point of our syllabus, we need to see them as points of intervention for language and mathematical knowledge. So we intervene to help students to expand what they know. And if we look at the New South Wales curriculum, we're not going to look in detail because this is where you'll be looking in your particular discipline areas. The content is organised around different strands and different ways of organising. So we don't have one way of organising knowledge because our discipline areas have particular ways of understanding the world. So look at what you're doing in your area and look at how that's organised. So if we I just want to give you some examples of how this might be seen in a practical sort of point of view. If you think about ways of reading, in English we have a particular way of reading. We seek to understand a position or a point of view. We look to the text to find elements, to build an interpretation, to reflect personally then on what we find. So we might be pulling out instances in a text and going, well, this is showing that. In mathematics, we're doing something else when we read. We're often reading to unpack symbols and see how that works with the words. So we have our symbolic rendering in one place, and we use language in another place to try and to describe, and then we're trying to fit these two together. So we're trying to read to match up what we see in the symbols matches what we've got in the continuous text, for example. Maths textbooks I found are quite interesting, and they have a lot of pictures that have nothing to do with what you're reading about. So we also need to be able to read to understand, should I look at that picture? Is it illustration? Is it decoration? Is it helping me with what I'm reading here? So it's just something I've noticed lately looking at maths books. A lot of decoration rather than building knowledge in particular ways. So students really have to work out what they've got to attend to when they read in their maths textbooks. In history, they might be reading for a different, it's similar to English in that they want to find an interpretation, but rather than going to one source, that idea of going to multiple sources and trying to then bring across from different sources into one understanding. In science, we might be reading proofs and reasoning towards a goal, so we're reading about somebody else's work, we're trying to follow their argument to say how they came to an understanding. So again, reading for a different reason from our other disciplines. And yet we might see common ways of reading as well. And the reading by Shanahan et al. Looks at how readers in history, mathematics and chemistry, for example, read in different ways, the way they attend to the text, which parts of the text they read. So that would just give you another an illustration of how this happens. We might think about how we use maths in different areas. Now, English uses all sorts of text to build English, to build not just that sort of literary understandings, but the literature, not just the literature understanding, but also literacy and language. So you find that English goes to all sorts of texts, and sometimes there's data interpretation. So in English, students have to be able to read data, or have to read a map, or have to read some other numerical data, or prompt, we might call it, in order to build up a situation, or sometimes to write something creative, which is often difficult to do. So, but often it's to write an interpretation, a technical. So when we're teaching technical English, again, that more content area literacy. English may have a lot of maths that we don't even really notice. So sometimes we have to be very careful to teach the graph or teach that data set so students can understand the maths to be able to do the language. Of course, history has so much numeracy involved in their mapping, in looking at data. So part of the source might be numerical sorts of attributes to be aware of those sorts of things. In science, of course, there's a lot of numeracy around knowing measurements, building data sets, being able to pull down the maths, the numeracy to be able to do the science is very integral to that sort of work. And of course in maths you've got a lot of numeracy, but often what we're trying to do in maths is then looking at what does that mean. So it's not just we get the answer, but have we got the right answer? Does that make sense? Yesterday I was looking at some of my own data and I suddenly realised that it didn't make sense. What I was saying was the average because the numbers didn't add up, and then I realised I had transposed 2 lines of data. So being able to look at information in numbers and then see if the numbers make sense and be able to work out where the mistake is a numeracy activity which we need to be able to do in maths, not just doing the maths but making sure it makes sense and checking our answers, I guess. In terms of vocabulary, of course, science has a lot. Science is quite interesting. It's concerned with processes as well as things, but we do a lot of these processes that we then make into nouns. So we talk about oxidization as a thing, but actually it's wrapping up a whole process of oxidizing in some way, like filtration. So what can happen in science is you as scientists move straight into the understanding that filtration is the process of filtering, without the kids knowing that that's the same thing. So we just need to be very careful in science. There's lots of vocabulary words, of course, but then the science vocabulary itself has these, you might call them technical words, but I want you to understand they pick up something else. So photosynthesis, great word, great idea, picks up a whole process. So just making sure that students know what you're talking about rather than just as a word, what is underneath all these sorts of words. History, again, we get this movement as we were talking about this movement from actions over time to concepts. So we talk about discovery and discovering things, and then we go to concepts such as colonization, which is the whole process, like science, of a colonizing action, which could include discovery, but making sure that students understand when we use this word all the sorts of things that presumes, I guess. In mathematics we do the same sort of thing. Our processes of subtraction, multiplication, we use those very early, so there's often students know that subtraction means to subtract, but when we get to things like correlations, so making sure that when we use these sorts of words that the students understand what's implied. And just one more here when we're looking at PDHPE. It's an interesting sort of, I guess, 2 types of learning or knowledge put together. We have this sort of action in sport when we're going out and getting the kids to run around, all that sort of thing. And then we have this health section, which is more like science, in fact, and would take up some of the processes and ways of thinking that might have more correlation or more relationship with science. So for PDHPE, there's quite an interesting there's linguistic sort of jump here between spoken sorts of ways of dealing with knowledge. We go out and we tell, and kids tell and we talk, and then when we come into the more written, formalised types of work. So helping the students to see how we change in our formality. When we're outside and we're shouting at each other and how to do things, and then when we come inside for a better location, and then we start to write in formal ways. So making sure the students are moving between those forms of the language. And of course, when it comes to symbols, there's all sorts of symbols. That's another part of both literacy and numeracy, being able to understand what we're meant, and the specific and particular symbols that are shorthands in our particular discipline areas which we want to use. So really we want literacy and numeracy across the curriculum in your head. So when you're thinking about the curriculum, you're thinking about what literacy and numeracy is being presumed. How do disciplines organise their knowledge base? Is it like other disciplines? Is it unlike other disciplines? How does language help to understand and represent that knowledge? And how does mathematics help to understand and represent that knowledge? And so for you, the challenge as you are engaging wholeheartedly in your literacy and numeracy across the curriculum lessons or classes, trying to take out some of those strategies that deal with text, both to read and to write, and how does that help you and how does it help your students to learn in their disciplines. And so with that, I will leave you for this lecture and wish you good luck in your reading and thinking about literacy and numeracy over this coming week.